Okay, so for number 26, we want to see if this geometric series is convergent or divergent. And it's convergent if the absolute value of the ratio is less than 1. So this thing here that's being raised to the power of n. And this is because our geometric series, we're just adding these terms infinitely, right? So as we keep adding them, we want this ratio to get to 0, or the limit to be 0, because at some point we're essentially going to be adding terms that amount to 0, so our total sum is not going to change, and therefore it's going to be convergent. And that's only possible if you have, say, like 1/2, and you raise it to something that's very large, like 1,000,000, that's going to be 0, practically. Whereas if I have the absolute value greater than 1, and I raise that to a very large exponent, like 1,000,000, that's not going to converge to 0. So what I want to do here is rewrite it, 26, so from 1 to infinity of e to the power of n over 3 to the power of n minus 1. But right now we have a problem because our geometric series, the first term has to be a times r to the power of 0, right? Which is just going to be a by itself. But right now, since my index is 1, if I plug in my first index, I'm going to have e to the power of 1 on top, and on the bottom, 3 to the power of 1 minus 1, which is 3 to the power of 0. So the term on the bottom is fine, but the term on top is not, because the index is not correct. So we really want to just evaluate e to the power of 0 on the first term, which means, and I'm just going to first do this here, which means that I want to turn this into I want to multiply this by e over e, because if I do this, this is the same thing as going e to the power of n times e to the minus 1, right? This e on the denominator is e to the minus 1. So what I'm going to do is I'm going to combine these two terms into a single exponent. So I'm going to rearrange this guy that's in the middle, I'm going to put it outside, and then times e to the n minus 1, because what I did here was I merged these two terms here. So this e times e to the power of n minus 1 is the same thing as just e times n. So I'm going to rewrite this as e times e to the n minus 1 all over 3 to the n minus 1. So if I do this, now I'm just going to rewrite this so that I can combine this into a single ratio. So the sum from 1 to infinity of e times e over 3 all over n, all to the power of n minus 1. And now this works because if I plug in my first index, well, that's just going to give me e over 3 to the power of 1 minus 1 to the power of 0. So now my first term has the ratio to the power of 0, so it works out. And so we can clearly see here that my a, so the term that's being multiplied, the constant, is e, and my r is e over 3. Now notice that the absolute value of e over 3 is definitely less than 1, so it means that this sum here, it converges. Now if it converges, we can then use this formula here to find the total sum, right? So what I have is that the sum from 1 to infinity of e times e over 3 to the n minus 1, that's going to be a, which is e over 1 minus r over 1 minus e over 3. And that is it for problem 26. This here is the result of our sum.